Today in JEE Math, we are going to see examples based on the greatest integer function, and I will tell you the tricks for each of them. So watch the video till the end. So the greatest integer function, also called as the floor function, denoted by the square bracket, gives the largest integer less than or equal to the given real number. So for example, minus 2.6 GIF function gives minus 3, but for 2.6 it gives 2. So we start with the example in which we have to find the domain of the given function. 4 options are given, so it might be confusing. First of all, in the denominator, you are having square root, so always it should be non-negative, but it cannot be 0 also, because in the denominator you cannot have 0. So strictly, the denominator, that means box x square minus 3 box x minus 10 should be greater than 0. Now this is a quadratic function. Factorize it, you will get 2 factors, box x plus 2 into box x minus 5 greater than 0. Now what will this give? Either box x greater than 5 or box x less than minus 2. Check it out. Only if these two conditions are satisfied, your inequality will be greater than 0. Now the first case is box x less than minus 2. That means the greatest integer function value should be less than minus 2. So which is the next integer value less than minus 2? It is minus 3. Now if your box x should be less than or equal to minus 3, what values can your x take? X should be less than minus 2. Maximum possible integer value is minus 3. So your x value can be anything which is less than minus 2. Even if you are having x as minus 2.5, the box x value will be minus 3. So this is the trick, or this is the rule. Second case is box x greater than 5. That means the minimum possible integer value is 6. So x should be greater than or equal to 6. So the domain, or the values of x, are minus infinity to open bracket minus 2 union close bracket 6 to infinity. First example, we have understood the definition of the greatest integer function. Second example is of moderate level. The value of the integral I is equal to integral of x square e raised to box of x cube dx. You have to find the value of this integral, and the options are given over here. First of all, since x cube is given, you will be taking x cube as some t. So now, as usual, this is a substitution method for integration. So when you take the limits, if x is minus 1, obviously x cube will also be minus 1. So t will be minus 1. When x is 1, t will be 1. So now I will be 1 upon 3 integral minus 1 to 1 e raised to box t dt. Now over here, again, use the definition of the greatest integer function. Now the whole interval is minus 1 to 1, and you can have the points in between. The points of discontinuity, we can say, can be minus 1 to 0 and 0 to 1. You will be having two terms over here, correct? So now evaluate for both the terms. In the first case, when your t is between minus 1 to 0, then the greatest integer function of t will return the value minus 1. Again, why? Because, for example, if you are having t greater than or equal to minus 1, means, for example, if you are having minus 0.6, the greatest integer less than or equal to minus 0.6 will be minus 1. So in the first case, it will be minus 1. While in the second case, when t is between 0 and 1, again by the definition of the greatest integer function, the value of box t will be equal to 0. For example, if t is 0.6, then the greatest integer less than or equal to 0.6 will be 0. So now in the first case, instead of e raised to box t, now we will have e raised to minus 1, and in the second case we will have e raised to 0. Now it is simple. It is a definite integral. When you integrate between the given limits and simplify, you will get the answer as e plus 1 upon 3e. The third example, suppose box x is the greatest integer function, then you have to find the values of x. That means basically the domain for this function, which is box of e raised to x square plus box of e raised to x plus 1 minus 3 equal to 0. One of the four options would be the answer. Again, first of all, we start with the substitution, that e raised to x equal to t. So now it will become our equation, box of t square plus box of t plus 1 minus 3 equal to 0. Now here, remember, By the definition, what is the trick? Box of t plus 1 can be simplified as box of t plus 1. Remember, for any integer I, if you are having box of x plus, say that I, since I is an integer, you can take it out. So box of x plus I will always be equal to box x plus I. I have shown as an example over here. So now it is a simple quadratic equation. When you solve it, you will be getting two values, box of t minus 1, box of t plus 2. So box of t equal to 1 or box of t is equal to minus 2. That means the greatest integer function of e raised to x equal to 1 or greatest integer function of e raised to x equal to minus 2. But remember, minus 2 is not possible because you cannot have e raised to x as this negative, any negative number. Now here comes the trick or the definition of the greatest integer function. If greatest integer function of e raised to x gives the value 1, that means your function e raised to x lies between 1 and 2. What is the reason? For example, if e raised to x has value say 1.5, then what will be the greatest integer function value for that? It will be 1. Correct? So here, if e raised to x box equal to 1, then your e raised to x lies between 1 and 2. Now it is simple. E raised to x, 1 less than or equal to e raised to x and less than 2. Remember, not equal to but less than 2. Okay? Because if it is equal to 2, then the box value will become 2. Put the value of your x, that means you will be having, taking log on both the side, you will be having log 1 less than or equal to log of e raised to x less than log 2. Log of e raised to x is x into log e is 1. So you have log 1 is 0. So you have x between 0 and log 2. 0 less than or equal to x less than log 2 with the base e. We have seen how examples on greatest integer functions can be solved easily. For more examples on JEE Math, subscribe to the channel.